Hello, my fellow YouTubers. This is Roy back again. Who I got out there? What's going on, Jason, my world traveler friend? Yeah. What's going on, buddy, man? Watching your videos. They're all over the place. I love it. Let's start off with, let's get the wheel turning. I'll first show how it's turning. I'm using this as my drive coil. It's a bifilar. I have it going into this 2N3055 transistor and this potentiometer. And I'm using these two batteries here right now as a run battery. And this battery here is a charge battery. This right here is the charge, is the voltage of the charge battery. So we'll see the voltage climb. Let's go ahead and start off with hooking up the battery. And then now I'll turn the wheel. You'll see my little signal light comes on. You can see the wheels spinning crazy fast. And that's the heartbeat of how many times the wheel is being pulsed through that bifilar coil. Now let's step over here. That's the spark gap. These are my capacitors. Right now we are coming out of the spark gap, which is right there, and we're feeding the top side feeding the top side of that plate there, and the bottom side of that plate goes directly all the way over here to earth ground. All right, so the bottom side of that spark gap is going to earth ground. We'll do a little test right here. And first of all, this is LED. This is LED. This is my antenna. What's going on, William? LED lit up. Wireless. Now watch this. Because the bottom of this plate, what I'm creating there is a dipole. And by having this plate right here is the coming off the high side of the spark gap. You see the spark gap going? So on the high side of the spark gap, we're going to that top plate. And the bottom side here is not connected to anything. So the bottom side of this plate is ground, okay? Is earth ground. And how is it earth ground? Well, it's earth ground because I got it coming all the way over here and go into this wire. So let's show what happens when you stretch out a dipole. And I'm using earth ground as one plate, and there's the other plate. Now watch this. I'm going to come over here to this let me get you set up here. Free hands. All right. So we are looking down at a pole that I have shoved in the ground, okay? And I'm going to go ahead and connect to the ground and watch what happens when I grab the wire. So we're expanding the dipole into the ground now. We're not even focusing on aerial above the ground, electromagnetic. We're doing electromagnetic reverse now. We're using ground. So that LED is lit up because one end I'm just touching, which would be the aerial, and the other end here, we're just using earth ground. Now, let's go ahead and disconnect the earth ground. Let me dial this in a little better. You can see that light. I'm going to add a little bit. A little less, a little more resistance. And we're going to disconnect to the ground now. And we're going to connect it to the bottom. So now the dipole is no longer going to earth ground. So technically this should not work at all. All right. Now, what will work though is if I hold it in my hand. Let's see if I have it hooked up right. Got a capacitor in my hand. Nothing. Spark gap still firing. Wheels still turning. Let's move into another experiment that I was working on, which is going to be the electrostatic side in here. I'm gonna throw some stuff in there. Some plastic. Oh, I got the wrong wire hooked up. Hold on. I thought so. You guys are still there? Give me a second here. And now we're gonna come off the ground side. Look, come off the ground side of the spark gap, and we'll connect that to the bottom. And then we're going to move the capacitor up. Now I should be able to hold this in the air. Not yet, huh? Bite me tonight. Here it is. Look at that. See, it's off. Back on. I put my finger on it. Let's see if I hold this capacitor. No. Let's try that side. Oh, I know what's wrong. Watch this. So I can't hold the capacitor, right? So I ground it out. I'm gonna grab it by the top. Look at that. Light bulb's on. So the wireless is charging the capacitor, and the light bulb, this is all wireless. And if I let go, nothing. And there's no charge in the capacitor except for just holding it up in the air. Over here, we're at 12.89, climbing to 12.90. That's right, and that's what we're working on here. Battery charging going up. 12 volts, 0.91 to go into 9.2. Got some good speed. I can adjust the speed with this potentiometer. This See the volts climb up on that battery that's charging. Well, it beats the heck out of using a reed switch, and it also beats the heck out of using a relay. On the core here, that's laminate that I shoved inside here. I got 150 feet of wire. It's a bifilar. I'm using 26 gauge and 26 gauge, and I believe 28 gauge. 150 feet each, evenly. And I'm using the laminate cores, little laminates right there. I'm shoving them in there, so they're making it perfect. I see there's a lot of ways to perfect this by knowing how to build your coils and what resistance to use based on what windings you use. So this is going to be interesting, diving into the coils per se. Like this coil here will not work off the 2N3055. I can get it to partially work, but there's a problem with the size of the wire and the windings. So I will dig in deeper into like the Benini part of this, and to get it more efficient. So the lessons to be learned in regards to like creating a electro dragon, I call it, electromagnetic field. It's pretty creative. I like the Figuerella pattern because you're able to, with that pattern from the machine I made, you're able to not have anything moving, and you're using an electromagnetic field of that moving field, but the field's technically not moving because it's lined up with a bunch of coils, and it's like an electro dragon, I call it. Anybody know about it out there? If you look at some of my past videos, you'll see I got into it for a while, and for some reason it keeps rearing its ass back up to the ground surface, and there's something more important about it that I need to go back into it, as well as the Bedini setup. I don't see well, I would say this. Using the coil, there's only one coil moving this wheel. Using the coil and capturing part of the energy back, I would say here, once I dig in a little bit deeper, that this setup here, the way it sits right now with that coil winding, I'm probably losing 30% of the energy. So out of 100, I'm using half of it for the prime mover, right? And then I'm capturing back 70% of the half. So I'm losing 30% plus 23% for just the coil itself, unless I use Leedskalnin style and wrap this with foil around the outside to capture. How to capture and mitigate the loss that's in that coil. That's the driver coil. so it loses no energy. So I think taking Bendini's setup and adding Leedskalnin to it um, for sure capturing and making it more efficient than Bendini was capable of making it efficient. That's a neon light right there for my backup so the circuitry don't burn up. That's my pulse signal that's telling me that it's the transistor between the collector and the emitter is firing. You see the volts climbing on the charging battery. This opens up a lot of doors, guys, because if you look at the big guy over here, I started using the wrong windings. I'm glad I stopped dead in my tracks. God works in mysterious ways. And Ed Leedskalnin's on my shoulder saying, stop, wait a minute. Learn about this. And to me, Ed was doing this in a way because if you look at his, let me grab a hold of something. If you look at his picture of himself holding the wheel, one thing you'll notice that he has a piece of white backer board covering that whole gap between the two stone walls. And that gap for sure is about, I say 6 to 8 inches wide, maybe even further. And he's got the bottles, all his bottles that he has, where they have a little, like a reed switch. Basically, he had 2 or 3 bottles hanging. The bottoms were broken out. They had contacts, like a 4-way contact, where it was electromagnetic. He used iron wire, and it would, I guess he did, it would flip on and off. So he was using that as a reed switch in this setup. And what you guys don't see here, that there's 2 rings here. You got the flange ring on the pipe, and then behind that is just another ring. So whatever he has right here, he has an identical one right behind it that you don't see. This thing is screaming, guys. I'm only using 1 coil. Now over here with the high voltage you're seeing, I'm using a flyback. Okay, I'll show you what I'm doing here. I'm using a flyback, and I'm using a driver to the flyback. I'm using 12 volts out of the battery into the driver. That battery is also rectified out of that, and that's going and charging the battery as the battery's being used. Coming out of the high voltage side of that flyback to one side of that Russian spark gap there, and the other side is coming out of the ground. But instead of coming off the ground, I came off the one wire that comes off the knobs on the side so I can make adjustments, which I never seen anybody ever do, because that's a high voltage transformer for a TV. So here is why you have a dipole here, and that's how we're getting the wireless, by just snapping the spark gap. What's going on, Marker in the house? Let's go ahead and disconnect the spark gap, and let's go right to the plates here and see what we get. All right, so we'll come out. Oh shit. Some damn juice in there. All right. Look how everything just stood up. Here goes like levitation, guys, with your electrostatics. Now, look at the stuff inside there moving around and watch what happens. Now, the top's not hooked up to anything. I don't think, is it? Yeah, I guess it is. The top's got the positive. Pretty sure. Yeah, the top's the positive and the bottom's the negative. So watch the stuff inside start moving. Let me grab some more of that sawdust. Electrostatics is the way Ed Leedskalnin used to get into his rocks, how he penetrated the rocks. That's electrostatics, guys. That was nice, guys. See what that aluminum did? So let me explain something here really good. So if you get aluminum in between this, we call it high temperature, I guess, right? High pressure. It had a lot of just a good bite about it right now. That was pretty interesting. Haven't had a good shock in a while. May have burned the light bulb out. Charging volts going up to 12.97 and 12.98, so we're getting some charge going in. Yeah, yeah, man, that was a good one. That was a nice one. Let's go back to the spark gap. Why torch that light bulb? Get another one. There we go. Got a red one this time. So, one thing I want to show you, let's go back to this real quick. So, on this right here, now, I got my little LED on, and you can see it's red, right? That's wireless. Now, I don't have the bottom plate on, so we're just using a half a wave right here. So, the right now, coming out of the flyback through the high voltage, going right here, I got the spark gap, I got the negative and the positive on the spark gap. And then coming up the spark gap, I'm just firing up this top plate. So we're using a half a wave, send it out in the air. So basically you can see it works, but it's very, very, oh, that's bright right now. So it's, you can see it's on. Now I'm gonna go ahead and reconnect that ground again. I don't have any more wire for the ground, so I guess I can't do that experiment. But I wanted to send it back into the ground because I think it's pretty amazing that when you make the dipole from up here and say 3 feet to the ground, that a ground rod becomes activated. Like right now, this rod that's right there is not going to light this bulb up because I'm not touching the ground. Oh shit, there it is, look. What the heck? Look at that. I'm not even connected to ground right now. It's doing it on its own. That's some good stuff there, guys. So it won't light up. It won't light up just like this right here. But let me show you something now. So if I grab a aluminum plate like so, and I add that like an antenna, and as long as I don't touch it, let's see where the antenna lights up the bulb. You can see the bulb's real lit right now. Pretty bright. Let me turn down some lightage. focus on the LED there. I think I'm going to try a safer route. So by using this antenna, this aluminum as an antenna, we're wirelessly making energy and we're receiving it. Pretty amazing. Let's see that's the heartbeat of the coil being hit. Look, we're getting ready to go to 13 volts. Oh no. Yeah, maybe it is interfering with the Wi-Fi. Why? You guys have crappy reception? A little worse than before, huh? All right, let's try this. Let's touch the wheel over here and see if we can get the light to light up. Oh, hell. Look at that. Ed's wheel ain't connected to crap. It's lighting the LED because of the signal. Oh, hell. Look how bright that is. So that's just the outside rim there. Let's go to the damn wheel itself. Oh, heck. Look at that. It's amazing, that electromagnetic signal. So the dipole is there, remember that. So if you understand anything about a dipole, the dipole is reacting between both of that. So it's stretching it out, and then it has a collapse, and then it goes boof, 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 and that sends out shock waves into the air. Very fascinating, I tell you. Very fascinating. That's it. Ride the wave. Ride the Schumann resonance. Going up to 13 volts on the battery, guys. Look at that. Recapturing. Recapturing. I just realized I had to charge my battery on my cell phone. How ironic. Isn't that ironic? Don't you think? So let's see from over there. And we already know edge wheel is not connected to anything. It's not even remotely anything going on. So how is that even working? That's pretty far away. Just right here to there. I mean, it's got a good 3 feet. It's a good good freaking distance. I'll tell you what you guys should use out there. If you try this at home, you can't get the LED to light up like I'm doing because you have to use a germanium diode. That germanium diode has to be facing a certain way. And germanium diodes are a crystal, and they're on the periodic table. And they also pressurize with ether. And what I mean by that is that a piezo crystal, piezoelectric, is how our muscles work. And every time you move the muscle, you'll have a contraction which will release electrons into your system of your body. So it's good to move around. That's why they say a body in motion stays in motion. And the more in motion you are, the more electrons you're releasing in your muscles because they're piezoelectric. So that's their crystal lattice about them in your muscles, the layers. So the germanium is a superconductor, semiconductor, and that germanium right there picks up really good. I can probably, with my Tesla coil, walk away with a little piece of aluminum, probably 60, 70 feet away. So it picks up that electromagnetic wave, but it's also, what it's doing is like a piezo electric or piezo crystal. It's reacting off the pressure of the ether. So that pressure of the ether is what's going on right now from this dipole is pressurizing the ether in its shock waves. And in the shock waves of this germanium, you're seeing the effect. So let's put this capacitor right there. So we know it's in the range. If we're picking up electric over there from Ed's wheel, we should be able to pick up something if this is just sitting here, because it's got a casing on the outside. I'm pretty sure that's damn aluminum casing. So let's see if anything from there. Nope. Anything from there. Nope. Nada. Nothing. Let's flip it, because maybe the poles have to be different on. Nope. One thing I want to tell you guys is, if you're ever having a tough time with your experiment, be persistent. To get where I'm at right now, I would be persistent. I'm working hard on this for 3 straight days. And for 3 straight days, I persisted, couldn't get it working. Frustrating. I can't even tell you how freaking frustrating. To where I'm at working, I'm just thinking about it. What did I do wrong? What ain't working? Why ain't it working? Anyway, holy cannoli. Just being persistent gets the job done. Thank you, Marker. I appreciate that. It's not easy to even some of the videos these guys make. Like I'll put my circuit up here so you guys can build your own. But I'll also show you again where all the connections go because it's really hard to follow some of these peeps. I don't know what the heck. But if you guys, anybody interested in learning how I set this up, I'd be happy to draw out a circuit, either post a video or send it to you for email. You know my email, VinnySt.Vincent@AOL.com. Don't be scared. Don't be shy. I'm your guy. Look at the battery right now is up to 13 volts and climbing. Is that amazing? So the more power I put in that, the more power goes into the battery, by the way. Then over here you just have happy-go-lucky Mr. Spark Gap. That wheel's just turning crazy. And we're charging battery over here. I can make that wheel go faster. That'd be nice if I can get a fluorescent bulb to light up. Let's see if I... This one's broken. I don't think these guys would even work with it. Not that one. I don't think any of these neons. These neons are shot. Oh, you know what neon I do have? Got these I just bought from the circuitry. I got one of these little neons that I bought for the circuitry. And let's go ahead and hook up. You see, that's not even on, right? So nothing's going on. Let's hook up a germanium to it. So we'll hook up this germanium to one of those little guys. I'm not sure if it's even going to work, but it's a AC light. Got a resistor on it. And we're going to need some type of wire. I'm sure it's going to act just like the... No. Nope, nothing. That ain't lighting up. I thought that would. Now I got it. So come over here. I got this light bulb. Look at that hissing coming out of that. Look at how much pressure's in that sucker. Woo-hoo-hoo-hoo! A little snappy. That is a flyback with a driver running it. Now it's a spark gap. Really? All right, so we're going to connect the bottom of this plate to the other end of the spark gap. So now we're not flaming over here when I'm touching them because we're coming up the spark gap. Now watch, let's get you down. Watch the material start to move down bottom that I put in there. See it now? I hook it up. See it all move out of there? Look at that. Florida jumping dust. That's a good one. I like that. That's sawdust, pieces of plastic, some organic material. Yeah, that's what that is. ZVS driver going in the flyback. Let's see where our charging went to. 1302, huh? Let's get some light over here. I'll tell you, it beats the heck out of the reed switch. It ain't easy to get a coil firing off a damn transistor, I'll tell you. Jesus, it's hard. Even if you're following the circuit diagram. All right, guys. Well, hopefully you enjoyed the video. This just opens up the doors for Ed Leedskalnin's wheel over there for me. He sure did, Tommy. He knows how to rope that dragon. Him and Figuarella. That patent Figuarella is so interesting. So interesting on that Figuarella patent. Ed said he has, in magnetic current, Ed says that he has also a generator, he says, right? A magnetic current. I have a generator that doesn't use magnets. Do I need to find that? In his magnetic current, he says, I also have a generator that doesn't use magnets. Let me see if I can find that sucker. And he says it doesn't make a lot of current. So what he says right here in regards to current, he says what magnetic current is. He says magnetic having to do with a magnet or magnetism. Current passing from one to another. Sometimes that flows as a stream. Now we'll tell you what a magnetic current is. Magnetic current is the same as electric current. Current is the wrong expression. Really, it is not one current. There are two currents. One current is composed of North Pole individual magnets and concentrated streams, and others is composed of South Pole individual magnets and concentrated streams. They are running one stream against the other in swirling screw-like fashion with high speed. One current alone, if it be North Pole current or South Pole current, cannot run alone. To run one current, you have to run against the other. Now, when he says he has this generator that doesn't make a lot of currents, he must be talking about it doesn't have a strong field about itself, because he's not using magnets to create it. So what is he talking about? If he's not creating, if he has a transformer, remember he has 10 machines, right? Let me get to that section. I'm going to find it, and we're going to show that Ed was making electricity without motion as well. At least he was. Well, here is when he gets into his patent. He says, now you and the field magnet are a generator. Suppose you had a wheel of many coils around the wheel turning. Then you would be making all kinds of light. Do not make the machine. I already have an application for patent in the patent office. I made 10 different machines to make magnetic currents, but I found a combination between field magnets end coil is the most efficient. So, 10 machines. Where's the section that he has one that has... I'm trying to find that. $13.02. We're putting a lot of damn pressure in that battery, aren't we, guys? That's 13 volts in that battery. You need a lot more pressure than 13 volts. And 13 volts, that means that sucker 13.6, I think. 13.3 maybe. 13.3 is a fully charged battery. So we're way up there. It's a lot of pressure in that battery, and we're overcoming that pressure by this back EMF. So right here he says, now I will, he says right here, you made magnetic currents in 3 different ways, but the principle will all be made exactly in the same way. Magnetic currents are made by concentrating, then dividing, then shifting the existing north and south pole individual magnets from one place to another. Now we'll illustrate how my best machine is doing it. And I believe it's that one right there, is doing it. I will only use one coil and one U-shaped permanent magnet without using the windings that the machine uses to increase the permanent magnetic strength. So right there, we're on the right track with Ed's wheel on having wire around the permanent magnets. I'm still looking for that section. Yeah. I don't see it because I'm rushing through the book. But he does. I'm going to find that though for you guys. Because what is he actually talking about? If he's able to make it without a magnet, so that means he's picking up ambient air. That means he's figured out how to tap the ground some way, or the electromagnetic dragon, without turning the wheel. Battery charger going up to 13.03. Hey Eli, accelerating particles. Yeah, sort of like the flyback. We're accelerating the north and south particles here in the dipole, and we're pushing them out into the ether. And then you can see how the germanium dioid recaptured. I would say that it responds off the ethereal pressure that acceleration is causing, or by that or the wow, you found it, page 17, second paragraph. Oh boy, Tommy, let's see what the hell he's talking about. Page 17, second paragraph. Oh yeah, you're right, Tommy, about why they can move so. Now I don't even have to read it. I know that in my head. Why they have to move, because they're flopping back and forth, and in between every stroke, they're picking up ethereal pressure, and it's putting magnets back into the wire. Oh yeah, good job, good job. Well, there's your power lines that are electro dragging itself because of the AC. AC is different though than snapping a DC back. That rate of change. Could be. Climbing up to 13.04. So, all right, guys. Well, I think 70 minutes is a long time for a video. I like AC through the PMH. AC through the PMH has Eli. AC through the PMH, because it's not DC and it's AC, doesn't really present a strong magnetic field. So that rate of change in the AC is really hard if you were looking, like, say, if you were trying to turn the wheel with the magnets, with the AC, you'd have to be able to control the frequency of that AC, I guess. You'd have to slow that shit down. Probably to about 30 hertz. AC 30 hertz, you'd be fine. Depends how you wind your coils too. All right, guys, leave your comments. Hopefully you enjoyed the video. We'll progress real quick with this. Real quick. I just got this running just about 2 hours ago. And I threw together just some stuff here, so I can't wait to push this one. This is phenomenal. So right here I can control the speed of the wheel. Now what I'll do is I'll turn the potentiometer and I'll make that light go down. Now, I can hear this coil thumping. Can you? Can you guys hear that thumping? I don't know if you can hear that thumping. Let me reach over here and see. Do you hear a thumping? Alright. Now watch. Now listen to that thumping. I'm going to move the potentiometer. It's changing the resistance in the circuit, in the trigger wire. It went away. It's not thumping right now. Wheel's slowing down. And I'm going to raise it up. There's the thumping again. That is so freaking cool that I can control the speed with the potentiometer on the wheel. Now I think the slower you go, I don't know at what point can it not push any more pressure into that battery. At what point? I mean, we're at 13.03. That's a lot of that's a lot of back pressure that battery's pushing. Now, with that coil like that, smacking, and we're getting the heartbeat with that light right there. Tapping into the ground is going to be pretty easy, especially to tap it into the Schumann resonance. Because the Schumann resonance, 7.8, between 7.8 up to 30 to 40 hertz. And recently, the Schumann resonance was screaming high, which was in the 40 plus hertz. And that was the changing time between the winter and I think spring equinox. So there was some kind of electromagnetic thing going on during that time that made the Schumann resonance high. So that means it was more of a pretty much, watch my finger, so it goes just like a sine wave. It goes like that, but it's traveling not only horizontally across the surface of our planet, but because the planet's round, it's also going, like if the planet was inside here, here'd be one plate, here'd be the other plate, and that plate has a mirror image, so it would be high side, positive or negative. It's going to have a plate in the middle of it, so it's doing this to that plate that's always causing a positive, negative, and then a positive, negative, and that's how that whole electromagnetic thing happens with the planet. So that Schumann resonance inside the two plates on the outside of the stratosphere up here, stratosphere here, which is your two positives, and then you would have your negative at the surface on both sides. So there goes, my top finger is the stratosphere, my thumb is the surface of the earth. And then you have the whole surface of the earth, and then you have the bottom again, and it starts over again. So think about the layout. South, north, and then there's a balance in the middle of the earth to where there's a neutral area, because that's where the stuff's being made from, the molten center, hollow center, molten outside the hollow center, it would have a pole like a neutral, then it would start back over. That's how you tap in. Yep, exactly, Tommy. So that's what Ed says when the the neutral is the equator. But you think about the layout I just said, because once you see that, you can see how there's a Schumann resonance on the. Let's just say that my voltmeter's the rock planet Earth, right? And then you got your atmosphere, and then your atmosphere on four sides. This is good. This is gonna be a good explanation. So basically, you're gonna have your outer stratosphere, down bottom your outer stratosphere, and you're going to have positive charges on two tops. So there's your positive up here, positive down bottom. Then you're going to have the bottom of where the ground starts, you're going to have your negative. There's your center right there, you're going to have your neutral. And then when the bubbles open up, then they slow down and cool down basically. They pick their poles, get caught up, and then there's a heavy presence like a static, that there's energy trapped between the top plate and the surface plate. Okay, bottom side as well. There's a static trapped environment. This is cool stuff. You can, if the Schumann resonance is firing sun rays across the top, sun rays across the bottom. Electromagnetic disk is what we are, so we're blocking those sun rays. Most of them are shooting around us, and that's where we get our tail end. So when the Earth turns around, you have, even no matter where you are on the Earth, you're always going to be at the tail end when it's dark. When it's dark in your area, you're at the tail end. So basically, you're having a stream run this way. Here's the Earth, or here's the sun. Here's the Earth. The sun's moving 70,000 kilometers per second, and it's going this way. This guy, Earth here, and the other planets all lined up are attached to that electromagnetically and being pulled along with it. And they're not really like traveling around the damn sun perfectly. They're traveling, and they're being dragged, and wherever they're sitting, they're spinning. They all still are going around this Earth or the sun because they're close in proximity, but they're stretched out as how we see it. It's pretty cool stuff, because stick that's able to travel upstream. Well, I'll tell you one thing fascinating you talk about upstream is that the St. Johns River travels from the top of Florida all the way down to almost Indian River, which is 100 and something miles long, 200 miles, 150 miles long lake or river, St. Johns River. It flows up north. It flows north. Look at the bolts there. Still going up. Back to what I was saying is, so with that set up there, that we're being dragged along from the sun, everything is sitting here spinning. They're close to proximity, but they kind of create and make a horn, like a spiral. That's how Mother Nature's doing it. And that's how we see this electricity moving one against another. That's how Ed describes it, that one goes against the other, but it moves together because of how the sun, the Earth, the other planets they're not traveling. If the sun is moving that direction and moving 70,000 kilometers, how is this frickin' planet going around the sun like this? It's never going around the front of the sun. It's no way. There's no way that can go in front of the vector field of travel of this thing moving fast. So it's got to stay dragged behind. It's still spinning it, which appears that it's still going around the sun, but it's dragged behind because this thing is pulling everything. You see that, how electric runs. It runs the same way as Mother Nature. Fascinating things. So the Schumann resonance pinging anywhere between 7.8 hertz to 40 hertz plus. To know what it is at a present time, there's got to be a way through resistance, like a potentiometer, like this setup here, to where you can tune this to be the coil, which is inside the pipe, which is connected to down to the ground, which is like a satchable reactor. And what we were trying to do is create that pipe to be something that's caught in between the wave of the Schumann wave. So if that pipe itself is pinging in a vertical way, the Schumann wave is going up and down, like a sine wave. So you're going to have your lows and your highs, your lows and your highs. And your low is at the center of the earth, not the other side of the earth, the bottom, but at the center. So you're getting to the center, which would be your hump down bottom. The ground surface is your middle. So you got 4 poles you're dealing with. 1, 2, 3, 4. Yep, you got 4 poles. Tap into that. When you tap into that, you're gonna get the expansion, you're gonna get the contractions, and once you have that, you have a ethereal differential, I would call it. And at that point, you should be able to tap into it. Life itself, aka, I love it. All right, you guys, you have a great night. Peace out. Never made an 84-minute video before, but this wheel's still turning. It's crazy. I'm in love with this circuit. Bedini's gonna be proud what I do to this sucker. All right, guys. That's gonna be awesome, because the techniques of this is going to be applied there. All right, Tommy, everybody, have a great night. Happy Friday, rolling into Memorial Day weekend over here at the other side of the pond for my good gents over there in Europe. On the other side of the pond, over here in America, we got Memorial Day weekend celebration all the way through Monday. Back to work on Tuesday. Let's go ahead and disconnect. And let's see this thing actually slow down. Man, I like that. Yeah, it's time to get out there. I guess just enjoy life, guys. It's goes by fast. So over here we're at 13.01. Well, this is interesting too. So now this is without the charge going into the battery. This will be the battery charge. Let's see what it drops to. Wow, we were at 13.5. Look at that wheel. So that's remember, that's the North Pole where I'm pushing out of that coil. And that's the North Pole side of the magnets. Look how the magnet's staying away. Good balance. So we got 13 volts. Wow. That's awesome, charging that battery. And you can charge multiple batteries. Let me plug this on one more time. All right, so we're plugged in again. And let's just see what that volts goes up to. Let's get the wheel turning. This is back EMF on top of the 13, right? This is 13.1, 13.2, 13.3. We're getting back up real quick. You can see the signal right there. That's the signal This ain't the signal generator, but it's just telling me that that coil right there, the prime mover and the back EMF, which is getting put into that charging battery, is climbing back up. So it only dropped to 13 volts, so it maintains. So it looks like it has to be what are these, intense? So it has to be half of it above the pressure of the battery. So if the battery's at 13 volts, there's a certain pressure of 13 volts provides into that battery. And in order to get it to charge any more, you'd have to up the voltage or up the pressure of your charging device for it to overcome the 13 volts of pressure. And you can see, look, we're back up to 13.5 on that. Interesting stuff. So like I said, this is learning time with the Bedini real quick, just to go ahead and well, yeah, I mean, basically, a system like this, say if you wanted to charge a boatload of batteries. I got a boatload. I got all these batteries I got for free, and they all need to be charged. So I'm gonna go ahead, probably tomorrow after work. Still gotta work tomorrow. I'll go ahead and I'll start taking my batteries. The battery that's running the wheel, obviously the more power you put in it, the more it charges. So I'll find a balance there of what I'll need for how much voltage in and what the battery charging capabilities are. I'll just go with that for a while. I mean, just to kind of see what can be produced, but I'm not sticking with just one coil. That should happen tonight. So I'll have this sucker, 2 as a driver, 2 back EMF. So that means there'll be another battery system on this side that I would be charging as well as that side, because I have enough of these batteries. And then we'll start putting meters everywhere, and we'll start to fine tune it to see if we can use less power to drive it, and see if we could see what we're getting out. I guess amperage for amperage. I don't know what to do from there, because all we're doing is we're charging stuff. But if we're charging and we're charging through a spike, you're not providing a current with the spike. So I get this whole thing with why this couldn't really be used for operation of running anything. But there's more to it that's missing. And I think I can get to the bottom of it. Are you